in this video, we want to integrate dt over t squared times the square root of t squared minus 16. And the way we're going to do this is by making trig substitution. We're going to let t equal 4 secant u. So the derivative of t, the derivative of secant, is secant tangent. And now we're just going to replace it. So on the top we have dt, which is 4 secant tangent du. And on the bottom we have t squared. Well, t is 4 secant, so if you square that you get 16 secant squared u. Again, 16 secant squared u. Now we're going to simplify the top of the bottom. And so first we have the 4 and the 16. Those are going to cancel. So we have 4 on the bottom. And then secant over secant squared is just secant in the denominator. Now inside I can factor out a 16 and have secant squared minus 1, which secant squared minus 1 is tangent squared. And so that's just going to be the square root of that. So the square root of 16 tangent squared is just 4 tangent of u. So now we're just going to rewrite it. So on the top, we have tangent u du. On the bottom, we have 4 secant u. And then multiply that by 4 tangent u. More cancellations happen. So tangents go away. And then I multiply the 4 and the 4 to get 16, so that can come outside. I have du over secant u, which that's just going to be 1 over cosine u, which is cosine of u. Now I'm going to integrate this. So the antiderivative of cosine is sine. And then don't forget to add a constant here. And recall that the substitution that we made was t was equal to 4 secant u. But we want to solve for u. That means that secant of u is t over 4. So if we make a right triangle, the angle is over here, that's u. Secant is 1 over cosine, so if I flip both sides, you can think of this as cosine of u equals 4 over t. That's going to be adjacent over hypotenuse. And to get the missing side, you just take the square root of t squared minus 16. So now if I'm looking at sine u, that's going to be opposite over hypotenuse, which is the square root of t squared minus 16 over t plus c. And so this is our final answer.